Hi, everyone, and welcome to Calendar Math with Miss Udo. All right, guys, let's begin. Oh, my word, I cannot believe it. We are in a completely new month. Well, if last month was May and next month will be July, what month is it? Last month was May. Next month will be July. That means that this month is June. Do you know what today is? Let's think. It is the first school day of the week. So, what does that mean today is? That's right, today is Monday. And if today is Monday, then what was yesterday? You guessed it, yesterday was Sunday. Well, if yesterday was Sunday and today is Monday, what will tomorrow be? That's right, tomorrow will be Tuesday. Let's take a look at our calendar. Oh, wow, the whole calendar is empty. Remember, a calendar assigns one number to each day of the month. And since our calendar is empty, that means that today must be the first day of the month. Let's say our date together. Remember, when we say our date, we start with the day of the week, and then we say the month, the number date, and then the year. Let's try it together. Today is Monday, June 1st, 2020. Let's say it together one more time. Today is Monday, June 1st, 2020. All right, littles, here's your problem for today. We are getting so close to the end of the school year, and so all of our problems are going to be about getting you ready for the next grade level. So this week, we are going to add two-digit numbers with base 10 blocks. Take a look here on the side. Our problem for today is 21 plus 7. When we add numbers that have two digits, we have to add our tens and ones separately. So let's take a look at our first number. That number is 21. How many tens are in the number 21? You can know by looking at the first number here. So how many tens are in 21? Did you say 2? If you did, you're absolutely correct. So we're going to place 2 tens on our chart. Let's look at the second part of 21. The next number is 1. How many ones are in the number 21? That's right. The number 21 has 1 1. Okay, well, let's look at the next number. The next number is 7. Are there any tens in the number 7? No, there are not. Well, how many ones are in the number 7? That's right. The number 7 has 7 ones. Let's count them out together. 1, 2, 3, 4, 5, 6, 7. Great job. Well, to figure out what 21 plus 7 is, we're going to add all of our base 10 blocks together. Remember, adding means putting them together. So let's start with our tens column. How many tens are in our tens column? That's right, there are 2 tens in our tens column. What about our ones? How many total ones do you see? Take a second, count them. Did you say 8? That's right, there are 8 ones in our ones column. That means that 21 plus 7 equals 28. Great job, littles. All right, middles, it's your turn. This week, we are going to solve problems involving money by counting. And we are going to be shopping at my make-believe store, the Walmart. Here's our problem. It says, Justin buys ice cream at the mall. Each scoop costs 23 cents. He also paid an additional 5 cents for a cone. How much did Justin spend on ice cream? And if he used the least amount of coins possible to pay and received no change, which did he use? Well, let's start by figuring out how much he paid for that ice cream cone. What hints in your problem will help you figure that out? Did you see that the problem says that each scoop costs 23 cents? Well, let's look at our cone. How many scoops of ice cream did Justin buy? Did you say 3? That's right. He's got a scoop of vanilla, a scoop of strawberry, and a scoop of chocolate. And so we know that he bought 3 scoops and each scoop costs 23 cents. How can we figure out how much the ice cream costs? Did you say we could use repeated addition? If you did, you're absolutely correct. So we're going to add up 23 plus 23 plus 23. Let's start with our ones column. 3 plus 3 plus 3 is, that's right, it's 9. What about our tens column? 2 plus 2 plus 2. And remember, because these are in our tens column, it's really 20 plus 20 plus 20. And so what number goes in our tens column? That's right, it's a 6. So we know that Justin spent 69 cents on the ice cream alone. Does it say that he paid for anything else? That's right. The problem tells us that Justin spent an additional 5 cents on a cone. So what do we do with that 5 cents? Did you say add it to the 69? If you did, you're absolutely correct. So 69 plus 5 equals, you guessed it, 74 cents. So Justin spent a total of 74 cents on his ice cream. Now let's finish up our problem. The next part of the problem asks us, what coins did he use to pay if he received no change and used the smallest amount of coins possible? Well, what is the largest coin that we've talked about? Did you say the quarter? You're absolutely correct. And so how many quarters could Justin have used if he spent 74 cents on his ice cream? Well, let's break it down. If he used 1 quarter, how much money is that? That's right. 1 quarter equals 25 cents. Well, if we added another quarter, would we be over the 74 cents? No, we wouldn't. Well, how much total would he have if he placed down 1 additional quarter? That's right. He'd be at 50 cents. Could he use another quarter to pay? No, he couldn't, because an additional quarter would get him to 75 cents, and that would go over, meaning they'd owe him change. So what is the next coin down? A quarter is worth 25 cents. The next coin would be a dime. Do you remember how much a dime is worth? That's right, a dime is worth 10 cents. And so if he used a dime to pay, how much money would he have paid at this point? That's right, 1 dime would mean that he's now paid 60 cents. Can he use another dime? Absolutely, because if he uses 1 more dime, Justin would have paid 70 cents. Now, could we use any more dimes? No, because dimes are like counting by 10. And so if I use another dime, I'd then be at 80 cents, and Justin only spent 74. Well, what's the next coin? Did you say nickel? If you did, you're absolutely correct. But remember, we want to make sure that he spends exact change. And if I added a nickel, which is worth 5 cents, to my 70 cents, I'd be at 75. So I can't use the nickel. So what should I use instead? That's right, we're going to use pennies. Now, if we're at 70 cents and Justin spent 74 cents, how many pennies do I need to use? You guessed it, we need to use 4 pennies. If we use 2 quarters, 2 dimes, and 4 pennies, we would have exactly 74 cents and Justin could buy his ice cream. Great job, middles. All right, senior scholars, it's your turn. Today, we are going to practice finding volume of a rectangular prism. So, as a reminder, what is volume? Does anyone remember? Well, the formula for volume is length times width times height, and the volume is how much something can hold. So let's take a look at our image. Here we have a rectangular prism, and this prism is made of unit cubes. And so in order to find the volume, we need to first identify the length, the width, and the height. Do you see the length of our rectangular prism? Did you say 5 units? If you did, you're absolutely correct. Well, what about the width? That's right, the width is 3 units. Can you identify the height? That's right, the height is 4 units. So, what are we going to do next to find the volume? That's right, we would multiply all of these numbers together. So our volume is going to be 5 units times 3 units times 4 units. And so because we have 3 different terms, we're going to break them into pieces and then we'll put them back together. So let's start with the first two. 5 units times 3 units. Well, what is 5 units times 3 units? Well, we know that 5 times 3 is 15. But what about the end of our problem? Is it 15 units? Does this remind you of anything that you may have learned earlier in school? I'm thinking 3rd grade. Yes, the 5 and 3, the length and width would actually be the area of our shape if it was flat and 2-dimensional. And so while 15 is the correct answer, we have to say 15 units squared because we now have a 2-dimensional shape. Now, how are we going to finish out this problem? Because we talked about the 2 dimensions, so those are just flat shapes. Our shape has 3 dimensions. So what's the last thing we need to do? That's right, we've got to multiply the height. So we're going to multiply 15 square units times 4 units. And if we multiply 15 square units times 4 units, what do we get? Did you say 60 cubic units? If you said 60 cubic units, you're absolutely correct. Cubic units are used for volume because cube means 3 and it's a 3-dimensional shape. So we found today that the volume of our rectangular prism is 60 cubic units. Great job, senior scholars. All right, everyone. Well, thank you so much for joining me today on Calendar Math with Miss Udo. I'll see you tomorrow. Bye-bye.